Let's say we've got a circle of radius 4. If we stick that on the xy plane and put the origin at the center of the circle, then we get the equation x squared plus y squared equals 4. And now my question is, if you take that circle and you draw a tangent line at any point on that circle, what is the slope of that tangent line? Can you give it to me in terms of x and y? And there's a couple of different ways to do this. Probably the first way that you would try to do this is to take that equation, x squared plus y squared equals 4, and solve it explicitly for y. So you would subtract x squared from both sides, and then you would take the square root of both sides. And so you would get out y is plus or minus the square root of 4 minus x squared. And that plus or minus, it's breaking your solution up into two different pieces. And graphically, what it represents is the plus is where the y is positive, so that's the top half of the circle. And the minus is where it's negative on the bottom half. So you've got two different pieces. Then you could take the derivative of each of those pieces, and that's one way to get the solution. There's another way to do it where you don't solve explicitly for y first. That's actually easier, and it doesn't break the solution into two different pieces. So that's what we're going to do now. We'll take that original equation, and there y is still defined as a function of x. It's just defined implicitly instead of explicitly because you haven't solved for y yet. So in this implicit equation, what we're going to do is take the derivative with respect to x of everything in the equation. So on the right hand side, the derivative with respect to x of 4 is 0. On the left hand side, the derivative of x squared is 2x. And then to get the derivative of y squared, we have to use the chain rule. And the reason for that is that y is a function of x. So you've got a function inside of a function there because the whole function is y squared. So let's think of that y squared as f, the function f. So f equals y squared, where y itself is a function of x. Then if I want the derivative of f, that f with respect to x, the chain rule says take df dy times dy dx. So df dy here is just 2 times y using the power rule. And then dy dx is what we're trying to solve for in the end. So I'm just going to leave it as dy dx, or you may want to write it as y prime, just to write it a little more simply. But that's what I want to solve for now. I have this equation. Let's solve for dy dx. So let's subtract the 2x from both sides and then divide by the 2y. And when we reduce, we get dy dx equals negative x over y. That is your derivative at any point on the circle. So it's much more simple this way. You don't have to mess with the square roots. Moreover, there are some situations where you actually can't solve explicitly for y in some equation. And so you want to take the derivative in those, then you have to use this implicit differentiation. But there are other times when it's just more convenient, like this little example. Let's go ahead and think about whether this makes sense based on the geometry of the problem while we have this solution. So our solution says the slope is negative x over y. And there are a few points that we can look at that are really simple to check and make sure this is right. If you think of the circle at the top point and the bottom point, the tangent lines there are horizontal, so their slopes are 0. And those tangent lines are touching that circle where x is equal to what? They're touching right at the y-axis where x is 0. So if you plug in x equals 0 into our equation, we should get that the slope is 0. And you do. 0 over anything is 0. So that works out just like we expected. And then let's think of those two vertical tangent lines that you get on the left and the right side of the circle. Those two lines are hitting the circle right at the x-axis where y is 0. If you plug y equals 0 into the equation that we got for the derivative, you get something non-zero divided by 0, and that doesn't exist. We don't allow that division by 0. It doesn't work in our mathematical system. So that doesn't exist, and that's right, the slope of these vertical tangent lines doesn't exist. So all 4 of those points match up with what we would have expected. Let's look at a couple more points. If we take this circle and we look at the line y equals x shooting through the circle diagonally, the points where that y equals x line cross through the circle, it gives you 2 points where the tangent line looks like the slope is probably -1. So let's test that. If you plug in y equals x into our equation for the derivative, then you get -x over x, which is -1. So those also match up with what we would have expected. So using implicit differentiation, we got a pretty simple formula in a simple way, and it does work. It does match up with the geometry we expected.